Hi friends, I just wanted to make a quick video showing you how to do the video game problem from class today, in case that is helpful. In the lessons up to this point, we have been working with linear expressions. We reviewed how to simplify a linear expression and how to evaluate a linear expression for a given value of x. We will now begin our work with linear equations. When we solve a linear equation, our task is to find the values of the unknown that make the equation true. I'm going to highlight that because that's pretty important. And I'm going to highlight it in pink. When we solve a linear equation, our task is to find the values of the unknown that make the equation true. Okay, so here's our first example. Damien and his friends went trick-or-treating. The next day they got together and they counted their candy. Damien had twice as much candy as Nick. Beau had 10 more pieces than Damien. The following model and expression represent the amount of candy the boys have together. All right, the context today, I'm going to pick, what am I going to pick? I'm going to pick orange because that's just how I'm feeling. The context today is trick-or-treating. The clues, we get that Nick has, well, they don't really tell us how much candy Nick has, so we can say that Nick has some candy. We know that Damien has twice as much. Oh my gosh, my handwriting's bad. As Nick. And Beau has 10 more pieces than Damien. Sorry that my handwriting is so bad. I'm writing not totally in tablet mode. Okay. So then the second thing, show on the model and the expression which pieces represent the amount of candy each boy has. You might find color coding to be helpful. All right. So this part right here, which corresponds with that part of my equation, and that's pink, so I'm going to choose pink. That is Nick. That is Nick. I don't know how much candy he has, but that's kind of our basis. Everybody else is compared to Nick. All right, then let's use a different color. It's kind of contrasting, maybe yellow. So this part right here, that part right there, those are both represent the same part of the situation. I'm going to do it in, I don't know if yellow is going to show up, but we're going to try. So this is, Damien has twice as much candy as Nick, so this is Damien. That is Damien. All right. And then the last one, let's choose a nice contrasting color. This whole bit is the last person, which was Beau. And for some reason, I had a random, there we go. Okay. Okay. So from here, which we're going to see on the next page, but I'll go ahead and kind of remind us, and I'm going to use purple for this. I could, if I wanted to, I could rewrite this expression in lots of different ways that would still be equivalent. That would make things maybe a little more simple. So if I wanted to, see, I've got 1, 2, 3, 4, 5 C's. 1, 2, 3, 4, 5 C's in my model. I could write the expression 5C plus 10. The advantage of that expression is that it is more simple. The disadvantage of that expression is I no longer can look at the expression and see which part of the expression is Nick's candy, which part of the expression is Damien's candy, and which part of the expression is Beau's candy. So sometimes you're going to have to choose whether it's easier for you to work with a simpler expression like 5c plus 10, or if it's easier for you to work with a more complicated expression that gives you more information. All right, part 2. What if we also know that together the boys have 230 pieces of candy? Let's look at a model for this. So they're giving us more information. Okay, now that they've given us more information, we can actually solve this problem. So the model is the same. I still have, this part was Nick, and this part was Damien, and this part was Bo, right? I still have those different pieces, but now I know that all of them together equals 230. So C plus 2C plus the quantity 2C plus 10 and 230 are both linear expressions that represent the amount of candy the boys have together. When we set two linear expressions equal to each other, we create a linear equation. That is important. I'm going to highlight it. Oops, I don't know what's going on. When we set two linear equations equal to each other, we create a linear equation. A linear equation is an assertion or a statement that two linear expressions are equal to each other. Using the candy example, we can create the following equation. So you can see that equal sign is stating the relationship that the expression C plus 2C plus 2C plus 10 has the same value or is equal to 230. All right, solve for C, be ready to show your reasoning. There's lots of ways to get here. I'm not going to show that part, but I will tell you that when you're done solving, C equals 44. What does C represent in this context? In this context, because, so this part right here, just a single C with nothing else, this was the amount of candy Nick has. All right. So C, in this context, represents the amount of candy that Nick has. And then how many pieces of candy do each of the boys have? Nick has 44 pieces. Damien has double that, which is 88 pieces. And Bo has 10 more than Damien. 88 plus 10 is 98 pieces. All right. Okay, a solution to an equation is a number that makes the equation true when it's substituted for the unknown. In other words, on the example above, the solution is 44. Verify that when you substitute 44 in for C, the equation is true. So what that is saying, let's go up to the model. I think the model is the easiest way to see this. If I look at the model, I'm going to go ahead and erase all this. I don't need that anymore. I don't need it. I don't need it. Go away. Okay. So if I put in, can I make this a little bigger? Okay. If I put in 44 every place I see a C, then that whole bar should equal 230. So what I have there is 44 plus 44 is 80. Well, 44 times 5, which is, I'm not sure, I'm using my calculator. 44 times 5 is 220. So I've got this part right here is 220 plus 10, which is 230, which is the right answer. So that's one way to verify that we have the right solution. All right, let's go. Okay, perfect. It's important to note that when we create an equation, the two expressions on either side of the equal sign might be true for one value of x, as we saw in this example. No values of x, there's not a number that can be substituted for the variable to make the equation true, or all three values of x. Every number we substitute in for the variable will make that equation true. In this first section, we're going to study equations that have one solution. So, yep, that's what we're doing. I hope this was helpful. Have a great day. I'll see you later. You're the best.